and its exchange capacity, which clearly indicates to what extent I can load this particular biochar with the micronutrients if I wish to. Right, so these are characteristics of biochar, how much of sodium is there, magnesium, potassium, calcium, and I use this particular biochar with different weight percentages in terms of what is the composition of it. And if I use this, and I have cases, one is a control which is having 0 biochar, second is 0.1 weight percent, 0.25 weight percent. How the soil acidity has changed as a result of addition of biochar in the soil, how the mean height of the plant has changed, and how the dry weight, that is the extended growth of the biomass, has changed. And if you put this in the form of a table, you will find almost 30% increase in the growth rate. This is a urea tray, directly added urea loaded on biochar tray, and a control tray. The difference itself is self-explanatory, and can see how effectively the fertilizer is being used. Ultimately, what is your objective? Your objective is to use that added fertilizer. Okay? And let me now turn to the last part, another 10 minutes, and stop it there. Disinfection of potable water using hydrodynamic cavitation. So let me just explain to you what is hydrodynamic cavitation. The problem with water is contamination in the drinking water. Sewage infiltration, animal waste, fuel and chemical leaks, naturally occurring minerals, all these are coming, but we are currently targeting only the microbial pollution which is being introduced out here. So what is hydrodynamic cavitation? This is just an introductory part, forget about this for the time being. Let me just go to this. What is cavitation? Professor Gupta was telling me yesterday that he told you about how cavitation can be avoided, right? Or why the cavitation for the pump needs to be avoided. Indeed, it needs to be avoided. But at the same time, can you imagine the fact that if cavitation is capable of doing a damage to the pump impellers, does it not mean that it has got huge amounts of energies associated with it? Can I harness that energy to bring about physical, chemical, biological transformations? Ultimately, whenever I am carrying out any transformation, I need to supply energy, I need to take out energy. And I am sure people have learned that either to carry out transformation, I supply heat energy, I supply microwave energy, I supply radio wave energy, I supply electrical energy. Similarly, I can supply sound energy. It is in one particular form. When I am speaking to you, is there any chemical transformation occurring within you because of my speaking? Of course there is. You are trying to understand, so chemical changes are occurring in your brain. Now they are getting stored. The memory is being utilized through those chemical changes. It's like a pen drive where you are loading a certain amount. Pen drive is more efficient than your brain. Your brain is much more capable of filtering out the useless information. So at the end of my lecture, I am sure you will remember about 10-15% of it, but that 10-15% of it is going to be real useful to you. The rest of the things, forget it, doesn't matter. Nice pictures, nice movies, nice videos, fine. Even if that 10-15% of retention which has been done has been retained as a result of me spending energy, where I am using energy to produce sound, and that sound is bringing about physical-chemical changes in your head. Similarly, if it can bring about physico-chemical changes in your head, it can also bring about physico-chemical changes in the environment, and indeed that is possible. So there are two modes of producing cavitating condition. One is called as acoustic cavitation and second is called as hydrodynamic cavitation. Acoustic cavitation is a passage of ultrasound. Human ear is capable of hearing from 16 Hertz to 16 kilohertz. That is 16 Hertz to 16,000 Hertz frequencies. Dogs can hear significantly higher, and that is why when you put up a recorder or whatever, dogs can hear, and the music doesn't appear there, because what it sounds to you as a music, it sounds to dog as a noise, as a result of which dogs get uncomfortable. You have the capability of listening to 16 hertz to 16 kilohertz. If you use frequencies in excess of 16 kilohertz, that is called as ultrasound. And sound, you all know, is made up of a rarefaction cycle and a compression cycle. It's essentially a sinusoidal pressure wave. Now imagine in the rarefaction cycle where the pressure is gradually reducing, if the pressure becomes equal to the vapor pressure of the medium through which the sound is propagating, that medium is going to spontaneously vaporize. Correct? It will form a vapor bubble. Relationship between boiling point and pressure. As the pressure reduces, the boiling point goes down. So if I am able to reduce the pressure and equate it to vapor pressure, spontaneously a cavity gets generated. It continues to grow, and then during the subsequent compression cycle, it cannot sustain itself and it has to collapse. Now the collapse of the cavity is capable of generating huge effects. So this is acoustic bath. You might have seen an acoustic cleaning bath where cavities are getting generated and they are collapsing. And this is hydrodynamic cavitation. Using Bernoulli's equation, you can tell if there is a reduction in the cross-sectional flow area, the velocity increases. Increase in the velocity will result into a decrease in the local pressure. The cavities are going to get generated, and as the pressure recovers further downstream, these cavities are going to collapse. Collapse of the cavities will generate these type of conditions. What you see here, temperature exceeding 5000 to 10,000 Kelvin. Surface temperature of sun is 6500 Kelvin. Surface temperature of sun. So you are creating many such miniature suns within your system. And if you happen to be near that particular system, let's say you are a microbe and you see this sort of a temperature, then obviously you are going to get damaged. I have always given a simple example. I have, let's say, a candle. Candle has a flame, and I am moving my finger through this particular flame. If I move it very fast, before the heat transfer has occurred, I have escaped the flame. But if I move it very slow, obviously I am going to get burnt. So even though these temperatures are reached, these temperatures are lasting for a period of micro to nanoseconds. As a result of which, it is sufficient to kill, but many a times insufficient to destroy the enzymes within the system. So the enzymes can be retained. You can break the cell, recover the enzymes. So this happens in the case of symmetrical collapse of the cavity. A symmetrical collapse of the cavity is what was explained to you of the damage due to cavitation phenomena. When you have a solid surface, when the cavity size goes on reducing, the liquid will start rushing from all the directions to fill up that vacant space as a result of reduction in the volume of the cavity. Liquid is 1000 times more dense than vapor, approximately. As a result of which a huge amount of momentum is associated with this onrushing liquid. Now these momentum will keep on compressing the cavity, and the cavity compresses at a velocity which is higher than the velocity of sound, which is 1500 meters per second. But if I have a solid boundary here, then this solid boundary will not allow the liquid to go from this direction. So the cavity distorts itself and it collapses asymmetrically. Asymmetric collapse of the cavity creates a liquid jet having velocities in the range of 200 to 300 meters per second. It's like a jet cutting action. And this jet cutting is the one which produces pits on the solid surfaces of your impellers, responsible for cavitation damage. Okay? But imagine this is not an impeller, but this is a microbe. What will happen to that microbe? The microbe is going to get shredded. Microbe is going to get killed. And if this microbe happens to be a pathogen, a bad microbe which is likely to give you a disease, then can I not utilize this phenomena of cavitation and the collapse of the cavities to keep on killing these particular microbes and disinfect my water? That's precisely what was done out here. So what was done is this particular hand pump, and this is the bottom wall of the hand pump. This is a device which keeps, this is a load check valve, and this disc keeps on moving up and down depending upon the stroke of the pump which you give. So the liquid comes through here and comes out through this in the form of an annulus. So there are multiple liquid jets which are coming out. Now if I control the area available for this particular jet in such a way that the velocities are same as what velocities are obtained in the case of Bernoulli's equation, then I can create cavitating condition in this particular region. And if I use these cavitating conditions, the water which is coming in, which is being pumped, is going to be effectively sterilized, effectively have a devoid of microbes. Right? This is exactly what was done. A lot of work has been done. It is not as straightforward and simple as I said. I'll show you the typical efforts which have been made. See, what happens is, we think that we have done something new, but you go back and look at the nature and see the nature has already done it. Nature is one which does not waste any resources. Whatever is the input and output for other is an input for something else. It carries out all the transformations using least amount of resources. And we can learn something from nature, that whatever transformations which you want to carry out, there is a lot of learning available from nature. This is a sea creature called a snapping shrimp. What it does, it doesn't understand what Bernoulli's equation is, but it knows what the principal operation of Bernoulli's equation is. So it has got these two pincers. It moves these pincers with such velocities that locally the velocities become so high that the pressure drops and becomes equal to the vapor pressure. So it creates, see, this is being moved up at a very high velocity. It creates a cavity, it throws the cavity, and the collapse of the cavities, it throws the cavities at the prey, and near the prey the cavity collapses. It produces a shock wave. It's like bursting an atom bomb next to my ear. I'm going to get knocked out, I'm going to get momentarily stunned, and then when that prey is stunned, this goes and eats it in peace. Right? It's like a pre-cooked meal or a knocked out meal which can be eaten out late. I want you to look at this very carefully and tell me what do you see out here. This part you have seen, you just have a look at the left hand side. What observations did you see? See a flash of light? Right? Now imagine sun is giving light. Why? Because it has got a surface temperature of 6500 Kelvin. Here I can see light. That means the temperature inside this collapsing cavity must have reached those sort of temperatures. This phenomena is called as sonoluminescence. That is the luminescence which gets created as a result of extreme temperatures which are generated in the collapsing cavity. If we can control or have a control over this cavitation phenomena, then it is indeed possible for you to manipulate this cavitation phenomena and bring out the cavitationally induced transformation much more efficiently, much more effectively. And we have used this particular phenomena for disinfection of potable water. And again, these are all the details, how you start, you analyze the piston diameter, all the geometry, the stroke length, the quantum of number of strokes which you can get. That typically when you are doing a vigorous pumping, you are doing about 40 to 50 strokes per minute when you are pumping water. As long as I get those kind of flow rates, cavitation does occur. You see the velocities which are getting developed. You can manipulate and calculate the changes in the velocity. I can calculate the cavitation number. This will tell me. This is again now done by doing a complete CFD analysis of this particular valve.